Here we have the 11:15 presentation by SensePost, A Tale of Two Proxies.
Hi. I'm just gonna clip this thing on here. See how that works out. Okay, are we all set? All good? We're gonna close the doors there hopefully sometime soon. Welcome to everyone to this talk, Tale of Two Proxies. This is the 5th year that we are presenting here at BlackHat in Las Vegas. So it's a kind of a monumental day for us. We also had a staff member that was working for 5 years for the company, Gareth. Thanks. Okay, so Tale of Two Proxies. Just to give you an idea where we come from, we're the same guys that did Wecto, Crowbar, BD Blah, the producers of Hacking by Numbers, Satiri, Putting the T in Cyber Terrorism, the directors of When the Table Turned, several Singer's fairy tales, and of course, the inspiration of the Matrix trilogy. Not really. So what does this talk about? We're going to talk about two proxies. They're very different. I'm presenting the Suru proxy, which is a web application proxy, and my beautiful assistant over here, which you can't see, well, there's nothing happening here. Okay, this. He's going to be presenting on a thing called LR, which I think stands for Last Resort Proxy, which is a generic TCP proxy. Now, these things must not be confused. There's two different presentations. It's basically molded into one presentation, and they serve very different purposes. So why do we need yet another proxy? So this is the Suru proxy, the web application proxy. Why do we need yet another proxy? We have a couple of proxies out there, right? We've got the at-stake web proxy, web scarab, Paros, all of those. So why did we build another proxy? Well, at SensePost, we do a lot of web application testing, and we really wanted something that can start off by doing a little bit better file and directory finding. Now, in Wecto, we have this back-end, system that finds files and directories, but it actually didn't work that much. It didn't work that well. So it was just not cutting it anymore. And we wanted something that can do proper fuzzing of parameters within a web application, and do it really intelligently, but don't do it too intelligently, because if you try to do it too intelligently, you give away a lot of the flexibility, and we'll see later what that means. So I was looking around at, you can see this orange sea of people sitting over here. I was looking at how these SensePost people are doing the testing that they do on web applications, and I found a couple of things. The first thing is there's no one-button web application assessment tool. So you can't press this button and all of a sudden you find all of the problems. And I don't think we will ever have something like that. There's a lot of people that attempted to do that, and in my opinion, I don't think they really got it right. What we've also seen is that people that are really good at web application assessments want to be in control of every request and response that they're getting back from the server. They want to be in control. They want to know exactly what it is that they are doing. And while they want to be in control, they also want to have. They're also performing some actions over and over again, but they're not performing it over and over again to the extent that we can automate it. This is kind of doing the same kind of thing. So what we wanted is to automate some parts of the process, but not have automation of the entire process. The other thing that we also found was that a lot of the lines between the web application and the web server were kind of blurring, and it was difficult to determine where the web application ends and where the web server starts, and the operating system. So we decided to build a proxy after all and see how we're going to do this, and it really didn't happen in one day. So I'm going to give you a brief history of where we get to this. We wanted something that would work like Nikto, but won't be fooled by friendly 404s. And so we created Vector in 2004. And there's a little bit of a pity because a lot of the people still don't know how that AI little, radio as a checkbox, how it actually works. And really the cleverness of Vector sits within the content comparison algorithm that we have. We created a tool called Crowbar early in 2005, and most people don't know how to use it, let alone know how it works, which is also a pity. Because here we expanded the thinking a little bit, and we said, we want to create a thing that can generically, because this is when I say something wrong when you do that. Okay. We wanted to create something that we can send generic TCP requests, not generic TCP, generic HTTP requests, and basically look at the response and see how the response differs from request to request. And at that stage, we found that Crowbar was really very powerful. It was one of the most powerful tools that we created up to that time. And we actually wanted to take that a little bit further into something that's a little bit more usable. We also wanted a proxy, normal kind of web proxy for EOR actually. And we took some code and we started butchering that a little bit, and we ended up with a thing that we called Suru, which we got kind of started on in early 2006. So if we say that people don't know how the AI options and the stuff works in Vector, let's explain it. And hopefully this will be the last time. The content comparison algorithm is basically compares two strings. Okay? So in Vector, it compares a response for a test case and for the real case. So if we look for something called, let's say we want to determine if login.pl exists somewhere, we would first do a base response request, that's that BRR, base response request, for something that doesn't exist, like moo.pl. And then we do the real test for login.pl, and we compare these two responses and see if the responses match. If the responses match, then of course the file doesn't exist, right? Because unless moo.pl actually does exist. In Crowbar, we do the same thing. We define there what we call a base response, and the user can choose what the base response should look like. And then for, let's say, a login page where we want to test the username and a password, we'd first test for a user called moo, password called blah, get that as the base, and then look for a real test, let's say with admin and a password of AAA, and see if those responses match. Again, if the response match, then we know that that login attempt was unsuccessful. If it doesn't match, then we know, something else happened. So for the first time since we're beginning with this, I'm going to show you how that content comparison really works, because it's really simple. It's not that hectic. So the first thing we do is we crop the header. If possible, if there's nothing in the body, then we take the header. But if there's something in the body of the HTTP reply, we crop that header, and we split the two strings that we want to compare on new lines, on close brackets, and on spaces. And that becomes two collections, like collection A and collection B. We count the blanks in both items, and then we have a little thing that basically just runs through the loop of collection A and collection B. It says if item A equals item B, then increment and counter. And if you found that word, break, so don't look for it again. And at the end of the day, return the counter times 2 divided by the sum of the items in both of the collections minus the blanks. So it looks a little bit like, looks a little bit like this. So if we have in action, we can see this in action. If I'm testing two strings, the first is I'm testing this, and the next word is doodle sakduk, and the next string is I'm testing this, and the next word is kaas krulletjies, then it becomes as follows. Collection A is, after it's been stripped of all those tags, the collection in A is I'm testing this doodle sakduk, collection B is I'm testing this kaas krulletjies. So the match count is I am testing in this, which is 4, right? blank count is 0. The number of items in A and B is 5 plus 5 is 10. So we return 2 times 4 divided by 10 is 0.8 or an 80% match. Okay. If, however, we have two strings that almost don't match, I was testing, and the other string, I am testing them things, then you will see that there's only 2 words that match, that is I and testing. 2 times 2 is 4, divided by 8 words in total gives me a 50% match. So this it's as easy as that, right? And it proved to be very effective. What we've also done is we've given then the user the ability to determine, to basically provide a fuzzy logic trigger to see how close they want to be to this. Look, if the two strings are exactly identical, it's going to be 1, right? The return is going to be 1. If they're completely different, the return is going to be 0. So this fuzzy logic trigger basically allows the person then to set the level to trigger when something is quite very different or similarly different. Okay, and you'll see how it works. I know it doesn't make sense now, but it's cool. You'll see how it works. It also, in Crowbar, we did a little bit of content extraction. So we allowed people to say, well, I want to, out of the response that comes back, I want to extract something. In this case, we say our start token is of about, and our end token is /B. Now, you know, if you Google for something, you say so many of about, so many hits, right? So we're extracting that part, and we're just running this with names. So you can see that the name Abby has 45,500,000 hits coming back. The name Abigail, though, has 21,900,000 coming back. So we can extract any kind of part of that response and put it in a file. Basically run through all of those names and actually extract the amount of data that's coming back from Google, anything that we want to extract from that page. That makes it nice for us doing certain things. Okay, now, so why does Wecto suck? Wecto actually sucks for the following reasons. It doesn't suck. Okay, it sucks a little bit, slightly. One of the features that the guys use when they're playing with Wecto is they use that back-end miner. They use it a lot, right, to discover files and directories. But what happens if the entire site sits behind a specific directory, like, say, big site or customer name, right? Then it's never going to find the directories that sit deeper within that. So the answer to that was, within Wecto, we say, well, you have to mirror the site with the mirroring option, extract the directories, right, and put those directories in the backend miner so that those directories will be found, so that recursively we'll find other directories within those directories as well. And that's fine. But what if the site has a form-based login? So let's say, you know, login password. Now, Wecto will never go deeper within that site because it doesn't know what that structure looks like. And that's why it sucks, all right? And what about doing other things? Like you request a file, okay, some strange form somewhere. Why can't we just look for all of the other extensions that we can have there as well? So you search for something called big site scripts, login.asp. Why don't someone look for login.zip and login.back and login. All of those other things as well? Well, in Wecto we can't do this because we don't know that that file exists. But if we have a proxy, then we actually could know this, right? And we could look for those things. And this is why Wecto sucks.